In this video, we'll cover vectors in the Cartesian plane. Before we begin, we'll cover some terminology. A position vector is a vector that starts at the origin. A displacement vector is a vector that represents a displacement between 2 points shown on the number plane. Position vectors are vectors from the origin to a point A, B. They are shown in column notation, as you can see A above B in brackets, where A is your x value and B is your y value. Notice that the vector leaves the origin. A displacement or relative vector is drawn anywhere on a Cartesian plane. They do not need to start at the origin, as seen in the example. When you're adding vectors, you can simply add the x coordinate and the y coordinate. Similarly, you can do the same with subtraction. Scalar multiplication involves multiplying a and b, or the x and y value, by the scalar. We will now answer a question. We need to draw the position vector and then draw a displacement vector equal to the position vector. On the right, you can see 1, 2. The 1 is our x value and the 2 is our y value. So we know our vector begins at the origin and goes towards this point. That is our position vector. If we were to draw a displacement vector, it could be anywhere on the Cartesian plane, but must be the same magnitude and direction. The blue vectors are displacement vectors for the position vector we have drawn in red. We will do the same here. Remember, 4 is our x, y is our 1, and it begins at the origin. If we were to draw a displacement vector, the displacements are in blue and the position is in red. Find the resultant vector of these two. Remember, we add them. So 6, negative 1 plus negative 2, 4 equals 6 plus negative 2 minus 1 plus 4. So the resultant vector is 4, 3. We can do the same with subtraction. To end the video, we'll do a quick recap. Remember, a position vector is a vector from the origin to a point. A displacement vector does not need to start at the origin and can be anywhere on the Cartesian plane. On your screen now, you can see adding and subtracting vectors. And remember, when you have a scalar multiplication, each coordinate is multiplied by the scalar.